mic is on. My name is Teacher Xuan. Now I would like to introduce our Water Rocket project. This project are prepared by our group leader Li Weihang and other 4 group members, which is Lis Daitong, Hui Sanzi, Zhong Ruizhe, and me, Teacher Xuan. Now, let me show you the material and the apparatus that needed to build the water rocket, which is compasses, scissors, ruler, plastic bottle, plastic board, color paper, golf ball, launcher, 560 ml of water, and the air pump. Now, I would like to pass this PowerPoint to our next member, Liz.
Thank you, Zheng Xuan. Now let me show you the principle of the rocket. Our rocket works on the principle of conservation of momentum. Our rocket uses water as our fuel, then we pump the air into the bottle to produce pressure. When the pressure is high enough, we will release the rocket. The rocket will then exert the pressure to the rocket to push it forward and pushing the water backwards to propel the rocket into the air. Next is our rocket design. It is built with a 100+ plastic bottle since it is strong, durable, and low density. It is also built in a cone shape to make it more aerodynamic. There is also a golf ball at the nose cone to increase the stability of the rocket while flying. Besides, it is built with fins at the end of the rocket to prevent rocket from spinning. Lastly, the nozzle is in small size to have a higher pressure while ejecting the water out of the bottle. Now, I am going to pass this PowerPoint to my member, Sanji.
Thank you, Liz. Now I'm going to show you out discussions of ways to increase momentum of the water rocket. We insert 1/3 of water into our rocket, so it will be able to launch at a higher acceleration. Other than that, we pump around 40 to 60 psi of air pressure to generate a high pressure to make the water exert the water to launch at a higher acceleration. Next, let's talk about the procedure. First, prepare all materials and apparatus needed. After that, cut one of the plastic bottle into half. Next, put the golf ball onto the bottoms of one of the bottle. Then connect the 2 bottles with tape. Cut the manila cuts and make the cone shape for the rocket head. After that, sketch and cut the cardboards into triangles, cut the fins. Next, use sandpapers to remove the glossiness of the bottles. Then, hot glue the fins to the bottles. After that, tape the color paper onto the bottle. Lastly, secure all the parts with more tape. After that, start the experiment. That's all from me. Now I'm going to pass this PowerPoint to Weihang.
Alright, thank you, Sanzi. Now, let's talk about the result. Due to our aerodynamic design, the rocket is able to fly for a long distance.
Let's check that out in slow motion again.
But still, there is still some precaution that you should know. Firstly, choose an open field that is clear of obstructions such as trees and wires. Never launch in a crowded area. Never stand directly over the launch pad while setting rocket on the pad or during launch. The launcher should sit securely on the ground and be more than capable of supporting the rocket safely during all aspects of operation. That's all from me. Now I'm going to pass this to my next group member, Richard.
Thank you, Weihang. As the conclusion, our group are pleased with our result, but we would like to change the length of our rocket. If possible, we would like to make our rocket longer. The smaller the air resistance, the longer the distance. That's all from us. Thank you for your time.